So we're all on the same page. Next time we have class, and please have your note packets out. Make sure you sign into your calculator if you haven't already. Next time we have class, you all have your first quiz, and that quiz is going to encompass simplifying radicals. They can be square roots, cube roots, etc. We need to know how to rationalize denominators and solve radical equations. You also need to know how to multiply two binomial radical expressions together, like 2 plus root 5 times 3 minus root 6, or something to that effect. But that's going to be next time that we have class. You'll have about 10 minutes, and there's, I think, 4 questions to go through and do. So where we left off last time was this. Did we do anything else? Okay. So let's go through and solve these out by taking a square root. Take a look at what's there, please. Let's take a look at what's there, please, for question number 1. When we go through and do this, we should see, after an initial look, we got 5x squared minus 10. Now, looking at that, Thomas, how many answers am I going to be getting to this? 2. You know that because this is a quadratic equation. Now, normally you would sit there and say, well, I solved this by factoring a quadratic formula. But if there's no middle term in this, this is kind of easy to go through and solve without a lot of higher level algebra. Emily, what would you want your first step to be if you were trying to solve for the x? Add 100. That's going to be the most efficient way to solve. So I'm going to add 100. It leaves me 5x squared is now equal to positive 100. What would we do next from here? Nick? Divide both sides by 5, and you get x squared is equal to how much? 20. Once we get to here, Marissa T., what would your next step be? So I'm going to take the square root of both sides, and when I get to here, I'd say x is equal to plus or minus the square root of 20. That's not an acceptable answer, though, because this reduces down further. Hands up, please, if you can tell me the biggest perfect square that goes into 24. So what would this be? We can simplify it out in our head. What would it be when you take the square root of 20? Yeah, so I'd say x is equal to plus or minus 2 radical 5. So far, we've only been able to solve, or we should have only been working with radicands that were positive. But in math, when we come to an impasse, instead of going through and hanging up the towel, we look and say, all right, let's try something new. In today's stuff, we're going to be working with what happens when you take the square root of a negative radicand. Here's our second question. You've got 2x squared plus 2 is equal to 0. This is a quadratic equation. You should recognize that immediately, which means you're going to be getting 2 answers. Kirsten, what would be your first step in solving this out? So I'd have 2x squared is equal to what? Can you keep going? What would you do? Divide by 2, so you get x squared equals. And your next step would be to take the square root of both sides. Now, normally you would stop and ask yourself, x is going to be equal to whatever times itself gives me a negative 1. Here's our problem. Nothing times itself gives you a negative 1. So what happens is this. We define what's called the imaginary unit, or I, and I is equal to the square root of negative 1. So now we've decided if we link this little unit onto it, we can now take the square root of any negative number. And negative 1 is a perfect square. What times itself gives me a negative 1? And that would be an I. So our answer to this is going to be x is equal to I. Is everyone okay with that? You should not be. Boy, you guys are sheep. Who can tell me what's wrong with what I have down there? We only got one person who sees it, too. We've done it 100 times. Terrific. Terrific. This has to still have 2 answers. it's still going to be a plus or minus I. Now, you know what the square root of 1 is, that's 1. The square root of 4 is going to be 2. The square root of 9 is going to be 3. The square root of all of our perfect squares stays the same. What we need to unlock now is this. The imaginary unit is I, which represents the square root of negative 1. And a complex number can be written in this form where a plus bi are real numbers. Now, that's the way that we would express our answer. One thing that we need to make sure that we get down, I have this listed out. My picture towards the end. Here we go. So here's one thing that you need to make sure that you have down. And it should be something that's kind of easy for you to understand. It's I to different powers. We haven't discussed it until now, but it's actually kind of easy. What is I to the 0 power going to give you? Not 0, 1. Because anything to the 0 power gives you a 1. What's I squared the same as? Well, I squared is the same as I to the first would just give you 1. I squared, can anybody tell me why I squared would be equal to negative 1? Think about how we defined I. Why would I squared be equal to negative 1? What do you want to say?
Because I equals the square root of negative 1.
I squared is the same as the square root of negative 1 being squared, which is going to be negative 1. Now here's the other part where some of you may struggle to see. I to the third power is going to be equal to negative I. Here's the justification. If I've got I to the third, I'm going to break that down. And there is a way that we can take the square root of this, because we would have I squared times I. But what is I squared equal to again? Hands up, please, if you can tell me what's I squared equal to or replace it with. Negative 1. So this would be negative 1 times I, which is negative I. Now, there's another way of doing this. You could remember it. If I'm doing this, look north and south. North is going to be 1. South would be its opposite, which is negative 1. Looking at this going east and west, I to the first, you know, is I, so I to the third would be its opposite, which is negative I. That's one way of remembering this. Another thing that you need to know is that these are cyclical, meaning it goes in a cycle. So I to the 0, I to the first, I to the second, I to the third. On top, at I to the 0, that's the same as, or sorry, I to the fourth would fall on the same place as I to the 0 power, which is 1. See how when we go around 0, 1, 2, 3, 4 falls up here? 5, 6, 7, 8, 9, 10, 11, 12. Who can tell me, please, what I to the 15th power would be equal to? You can count your way around. Some of you will notice that there's a shortcut in just a minute. Maybe you'll see it. We'll count our way around. We'll wait for 9 of you that can tell me what I to the 15th is going to be the same as. We got 1, 2, 3, 4, 5. What do we want to say? I to the third, which is what? Negative I. Now let's do this. Hands up, please, if you can tell me what I to the 100th power is going to become. Hands up, please, and there's a shortcut to it. Some of you will see it. I to the 100th power. You can sit there and puff like a chicken all the way around till you get to it. Look for the pattern. We got 2, 3 of you that see it. What do you want to say? Not negative 1. You could count all the way around. 1. Why is it going to be 1? Did you count all the way around 100 times? Oh, okay.
100 is negative 4.
Remember, it's cyclical by 4s. How many times does, we'll say it this way, every multiple of 4 is going to land up top. Does 4 go into 100? Exactly? Yeah. So I to the 100th is the same as I to the 0, which would be I. What about this? What about I to the 102nd power? Find a multiple of 4 that's near 100 and 2, and use that to count forward or backwards. Who can tell me what I to the 102nd power is going to be? We've got one person. 1I to the 102nd power. What would that simplify down to? Remember, think of the multiples of 4. What multiple of 4 is 102 or is near 102? We've got 2 people, 3 of us. Really? Really? Which is this? This would be equal to I to the 2nd, which is, here's what you see. I to the 0 falls here, so does I to the 4th, I to the 8th, I to the 12th, 16th. What multiple of 4 did you use, Tracy, get that answer?
Well, I didn't even look I to the 100 was 1, so I just went over 2.
You could use I to the 100th. Does anybody know another I you could use that would make us have to count backwards instead of forward around the wheel? 104, yeah. So if I said, all right, I know I to the 104th power, then I'd have to go, this would be I to the 103rd, this would be I to the 102nd. What about this? What about I to the 90th? Actually, let's change that. Let's do I to the 91st. Oh. Go through, list it out, count around if you need to, or find a multiple nearby that's going to help you. Tell me the multiple that you would use to get to it, and what I to the 91st would simplify down to be. What multiple of 4 is nearby. You could keep counting. You could still use 100 if you wanted to and count backwards. We've got one person that can tell me what I to the 91st would be. 2 of us. 3, 4. Sam? I to the 91st is not going to give you out a 1.
Negative I.
Why did you say negative I?
I counted backwards and that's I.
Which multiple did you use? Did you use 104, 100?
I used
100. Did anybody find a multiple nearby that might be more beneficial? 88. So if you start off at I to the 88th and know that that is up here, then you do 89, 90, 91 gets you to negative I. You could have also used one other multiple that's really, really close to 91. 92, and then count backwards 1. Now, when we give this always shows up on the test that we give at U of R to go through and do this. And it's I to the 324th power. Now, we'll caution you, because some people, for some reason, don't see those multiples of 4. So literally, and when you take a test at college, most of the time, you'll have a 2-hour block, and they'll sit there and you'll take the 2 hours to go through, and on the day that there's a test, even though it's 2 hours, most kids only stay at the test designed to be about an hour. So, and they have their they have their calculator, right? And this boy sat there, and he goes, now this was personally a little bit interesting for me, because normally after the hour, almost everybody's gone. So I hear this to start. Now, imagine you're in the middle of a test, okay? The person next to you is going through and doing that. And I know because they sat right near me. So I remember looking over, and it was this girl who maybe didn't hide her emotions very well, but literally was taking the test and went like this. Kept right on counting. And it wasn't like someone was knocking at the door like a woodpecker going to town on this step. Boom, 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 boom. Sitting there. And then they stopped for a minute. And then I regretted later on in the test, have to evaluate out I 507th power. So again, much like a chicken eating, you hear this, except the person next to them let out an audible obscenity directed at that person because they literally had to sit there. And again, just remember this. That was only 16. Okay? They had to do it 507 times after the initial 324. So we heard about 800 of those. Now, to make it even better, they screwed up their wheel of I. I to what power goes up top? 0. They had it as I to the first. So everything was off by 1. Now, was that the spirit of the question to make you sit much like a chicken would and peck your way around a wheel 324 times? I'd say no. Now, who can tell me what they think I to the 324th power is going to be? Well, find a multiple of 4 that's nearby, and hands up, please, when you can tell me what that's going to come out to be. We've got 1 person. We'll wait for 8 of you. 3, 4 of you. If you need to go through and peck around, that's fine, but understand people may yell at you and or throw something at you. You're going to do them all? Like somebody's at the door. Who can tell me what multiple of 324, what I to the 324th is? We'll leave it at that. Who can tell me what I to the 324th is? You seriously got 5 people? We're better than this. Find a multiple. If you don't know, use your calculator. There's just 4 times this. Maybe it's like, all right, well, what do you want to say? It's going to be 1. 324 is the multiply. So you can see why. Think about the spirit of the question. Do you really think that the goal of writing the question would be to see if somebody is capable of counting around a circle 324 times, followed by 507 times? Recognize the multiplicity of it, and we should be good. Questions on those? Now, once we have this down, there's one other piece that we're going to have to understand. We'll get to this before we start in. Let's ask this: square root of -1, square root of -4, square root of -9, square root of -81. Let's do square root of -24. Let's do the square root of -48. And the square root of -8. So we'll start off with the easy stuff. Notice the square roots are already given to you, so we want the principal answer, not a plus or minus. Look at what's there for the first one. What's the square root of -1? Sean K? There we go. It's going to be an I. Now, can anybody tell me what they think the square root of -4 is going to be? Piece together what we know. What do you think the square root of -4 is? 2 people? Not 4i. Nope. 2i. The square root of 4 is 2, so the square root of -4 is 2i. Who can tell me, please, what the square root of -9 is going to be? Hands up, please, when you can tell me that. 3i. Let's finish this off. Hands up, please, if you can tell me one of those remaining 4 that you can simplify. There's one that's real easy. Be a hero. What do you want to say? Now we've got to some tough ones. It's the same as the positive, except it's going to have an I in it. What can you tell me what the square root of -24? What would that simplify down to be? Think about the perfect square that goes into it. We've got 1 person that can tell me, 2. Any of those really are fair game. Close. He said 2 radical 6i. That's close. No? The I goes out front, so this would be 2i root 6, because it would simplify down to 2 root 6. Remember, the square root of the negative sign means that there's an I in front of the coefficient. What about any of the remaining 2? Look at what's there. Remember, the I goes out front, yeah? All right. Terrific. This becomes 4i root 3, because the biggest perfect square that goes into 48 is 16. Who can tell me what else we've got? Yeah? Outstanding. The only difference is now they have an I in them. That's it. Let's answer these, and hopefully these get real easy now. Let's take a look at what's there. Michaela, what would your first step be, please, in solving this question out? Okay? And when I do that, what am I left with?
-12.
So I have 3x squared is equal to -12. Let's keep going. Marissa D, what would you do from here?
Divide.
Good, so you get x squared equals how much? What's 12 divided by -3? -4. Corey, what would you do next?
Square root of both sides.
Now this is going to be an interesting one. What do we get, Royce, as our answer?
X equals 2y.
Who is outraged and offended right now? Look at, you've started a movement. Everyone is outraged. And don't throw chairs at me. And you can see, you guys are so mean to me. If there's one little mistake, you're so, the venom. You're like spiders. What? Terrific. Just remember, when we do it, and this again, when you take the square root, we have to get those two answers. Questions on those? Remember that plus minus, yeah? Because 4 is a perfect square, -4 will be a perfect square also. Let's simplify these down. Oh. Let's look and see what we get for the first one. Now this is not going to be plus or minus because the square root's given to you, but let's simplify and go forward. What's the square root of -25 going to be when we simplify this down? Philip, what do you say? Terrific. So now I have 5i. And what about 5i plus? Amanda P, what would we have for the second one? What's the square root of -49 going to be? All right. What can we do to go forward from here? What would I be left with? Or am I stuck? Add them together. What would I go through and get? Sean L? There you go. Take a look at B. You are good enough to do this. You actually did half of it all the way out already. Anthony, do you want to simplify down the -√8 or the -√18? Okay, so we've got 2i√2 minus, what about over on the other side? Trace?
3i/2.
Who can tell me what I get when I subtract those two? What would I be left with when I subtract those two? Because they're like radicals. We got one person, 2, 3 of you, 4. Yeah, -1i√2, which we can write out just as -i√2. Questions on that? That's simplifying radicals. You've been doing them enough now. We should be pretty good. How about these? And hopefully we can burn through these quickly. What's I squared equal to? Hands up, please, if you can tell me what I squared would be equal to. My heart's breaking in a million pieces right now in front of you. Terrific. What about I to the 40th? Hands up, please, if you can remember back to your wheel. Think about if you need to list it out again. That's fine. I to the 40th. What is that going to simplify to? We've got 5 of you. Michaela, what do you say? Think about the wheel. You start off, you've got I to the 0, I to the first, I squared, and I to the third. I to the 40th, what multiple of 4 is near 40? $36, or, so let's say you use 36. That means I to the 36 falls up top, right? So this would be 37, 38, 39, 40. What's I to the 0 power going to equal? 8 times I to the 82nd power. Well, we need to know what I to the 82nd power is. Go through and start counting around if you need to, or find a multiple of 4 that's near 82. What multiple of 4 do we want to use for this question? I to the 82nd. These are multiples, guys. This is 5th and 6th grade math. If you need to use the calculator, fine, but you've got to know your multiples of 4. We've got 4 of us, 5. There's a ton of different ones that you can pick. What multiple of 4 is near 82? Marissa T? What's that? 88. All right. So this, I make I to the 88. Now I need to find I to the 82nd, so this would be 88 here, 87, 86, 85, 84, 83. This down here would be I to the 82nd. What do we get if it's I to the 82nd? Negative 1. So this is 8 times negative 1, which is negative 8. You've got to link those multiples of 4 to the I. You could have used a bunch of different values. You could have used 80. You could have used 82, so you could have used 84. It doesn't matter which one you pick. It just helps if it's in the ballpark. Yeah.
So 82 is divisible by 2, so could you just go to I to the second?
No. Because so is 4. 4 is divisible by 2 also. Yes.
If I fight 4, like, which is 20,
Mhm.
that is like half
20 with the remainder of
2. So like,
2. Then you
go
can.
to 1 and then count 2 clockwise.
Careful, you go to 0 and count 2 clockwise. Go up to the top and go 2. Yep.
Was there like no other way to do that than like using the calculator?
I would say yes. Because we'll show you something towards the end. But keep in mind, for a lot of these, you won't have a calculator to do. On the reads, you will, and we'll show you a read shortcut. Okay? Let's go over now. I to the 266. Well, I'm going to sit there. This is negative 3 times something. I've got my wheel here. What multiple? Again, start trying. Take 4 times this value. Who can tell me what multiple of 4 I would want to use for 266? 266? You got one? 264, all right. So this is I to the 264. This would be I to the 265 here. This would be I to the 266. What's the value of that going to be then? Negative 1. So this is negative 3 times negative 1, which would be 3. Questions on that? Who used a different multiple? Which one did you use? What's that? No. I did the 65. That would mean this would be. That would be a heck of a lot of counting left over. What about I to the 23rd? Hands up, please, when you can tell me what I to the 23rd is going to equal. Think about and start counting around. Really? 4 of you? What multiple did you use? So 24 would be 1. I to the 23rd, that would be negative I. So this equals negative I. 12I to the 41st. Hands up, please, when you can tell me what your final answer for this would be. You got 1, 2, 3, 4. Really? We got 4, 5. What multiple did you use? So this would be I to the 40. This would be 41st. This would be I. That is a 1. So this is 12 times I, which is final answer. Questions on that? We start getting a little bit redundant. Let's do 4. Let's do out number 11. I to the 401st power. 4 times I to the 501. That would be 4. who can tell me the multiple, or actually I'll leave it at this. What is I to the 501st going to reduce to? Be able to find your multiples. We got 1, 2, 3 of you, 4, 5, 6. It's going to be an I, because I, what multiple did you use to count up to it? 500, yeah. 500 be up top, 501's right next to it. So this is 4 times I, which is just 4I. Questions on that? We're going to show you something towards the end. Now, you all did not know last year coming in, Cartesian plane. We didn't know lattice points either, which makes me wonder, maybe we played too much Kahoot. Now, we're going to graph out something called the Argand plane. Now, the Argand plane, when you go through and graph that out, the Cartesian plane is used for real numbers. It's an ordered pair x comma y. The Argand plane we go through and use to graph out imaginary numbers. Now, imaginary numbers, this is your, technically when you label it, this is your x-axis and this is your y-axis. You're still graphing out sort of an ordered or an ordered pair. Remember how we said before they go in the format A plus BI? This right here is the X part, and this is your YI part. Those are the directions on how to do this. And a lot of people will show you that a way to graph this, and it is incorrect, no matter what the Reach even says. For number 12, we are going to go through and graph out 3 plus I. Let's start with graphing out 3 plus I. This, if we're graphing this, this is the X and this is the YI. So it's -3 or 3? -3, which means I would go back on the X-axis to -3, which is here, and your YI value is a positive 1I. So I would go up to here, and I'm going to put a dot, and this would be -3 plus I. Now, this is where some lazy Larrys will stop. This is supposed to be a vector going from the origin, which is like a ray. So you draw an arrow with a point at -3 plus I. Which quadrant does that fall in? Second. So it always goes X comma YI if you're thinking of it in that respect. Now, hands up please if you can tell me which quadrant you think 2 minus 5I would get plotted in. Which quadrant you think 2 minus 5I is going to get plotted in? You got 1, 2, 3 of us, 4. We want to say, terrific. We would go over 2 because that's my X component. So this would be over 2, down 1, 2, 3, 4, 5. So this would be 2 minus 5I. Now I'm going to sketch from here to here a line, actually a ray, a vector going from this origin to that value. Questions on that? If you don't draw the ray, it's not wrong, or it's not correct. Let's go through and get these done in simplest form here. Now, let's do the parts of this that we can handle first. Take a look at 13. When we do out 13, the order of operations tells you to simplify anything in the parentheses first, nothing there. Next up is deal with any exponents. And I have something I need to evaluate out to a power. What would be the first thing I evaluated before I go and start typing this in? What do I need to evaluate out? What does this tell me? We could go through and find the value of I to the 81st, but I want to handle something before I even do that. How about the 5I to the 7th power? Both of those need to be raised to the 7th power. So go into your calculators, hands up please when you can tell me what 5 to the 7th power is going to be. 78,000, what is it? 125. I to the 7th times 3I to the 81st times a -2I. Now, we're going to multiply going across. because that's what multiplication is. You're going to multiply your coefficients, then we're going to go through and deal with the i's. When I multiply going across, hands up please if you can tell me what numeric value I get from multiplying my three coefficients. Use the calculator. You love it. We've got 0 persons that can type so far. Amazing. Amazing. We've got 1 person who can tell me what our coefficient's going to be. 2 of us. 3, 4. Oh, come on. What coefficients? Vicki, did you get what the value's going to be? 705. Is that what you said?
7,536. 750.
750. Okay. Now we need to figure out I to what power. I have 3 i's here, and we should remember our algebra rules from Algebra 1. When we have like bases, what do we do to the exponents if they're multiplied together? Add them. So I need to take 7 plus 81 plus 1. What's 7, 81, and 1 going to give me? 89. Now I need to figure out what's I to the 89th power the same as. Hands up please if you can tell me what I to the 89th power is going to be the same as. We got 1 person, 2. Find a multiple nearby. Terrific. So this would just be negative 468,750 I. Questions on that? Let's go and take a look at the next one. This one is littered with simplifications. First, let's evaluate out what I to the 488th is going to be. So use your calculator if you need to find a multiple of 488. Sorry, I'm going to find a multiple of 4 that's near 488. And hands up, please, when you can tell me what that would simplify to. Yeah? It's going to be what? 1. So this is 7 times 1 minus 3 times what's I to the 113th going to be the same as? Hands up, please, when you can tell me that. Oh, come on. 2 people. Remember your wheel? 3, 4 of you. 5, 6. No. It's not going to be 1. What multiple of 100 and or multiple of 4 is near 113? Okay. So if that's the case, you need to count back 3 from 0. No? What's that going to be? It's going to be I. Now we're going to do the same thing. We've got 5, 227. Go through and find a multiple that's nearby. What's I to the 227th going to be? We've got 1 person, 2. 3 of you. Negative I. And what about I to the 18th? Hands up, please, if you can tell me. This would be minus 6 times I to the 18th. What's I to the 18th the same as? There's 2 of you that know what we're doing. Outstanding. 3 of you. Are they going to know? You don't know. I hope so. You pick 2. Sean out. Now, let's simplify this out. This is 7 times 1. All right, I'm good at that. That's 7. Negative 3 times I would be negative 3i. Plus 5 times negative I, that's minus 5i. And at the end, I've got plus 6. What would you give out as your final answer? Yeah. Now, I'm going to show you something, and you can yell at me all you want after. Go to your calculators right now. Your homework is listed there, and I'll put the answers up at the end. Go to your calculators. Did everybody sign in? We're still waiting. We'll wait. Go through and sign in if you haven't already. Is the thing grayed out on the bottom? Turn it over and hit the reset button on the back. These are kind of pencil to do that. Now, what we're going to do is this. When you have, and again, here's, I guess, one of my biggest areas of concern. Last year, they literally prepped you to only take a Regents exam. They didn't prep you to actually do math. So, we're doing like legitimate, actual working with numbers and things that'll make you sort of successful when you go on beyond high school, and not some sort of stopgap. When you get to the Regents exam, that's when the calculator is available. That's why I'm shocked at how many of you guys scored in the 70s. Watch what we can do on this. And there's calculator gimmicks, and we'll show you all of them for June. But they're not math, they're gimmicks. That's the same thing as that guess and check garbage. Go over, please, to a new document. And what we're going to do is, we don't need to save anything that's there. What we're going to do is this, add calculator. Now, let's say I forget what my wheel of I looks like, but I know what it's structured as. Go in right now, and please press the pi button. Select I. No, sorry. Delete what's there. Go back and hit the pi button, select I. Now let's do I caret 0. What's I to the 0 power going to be equal to? Hit enter. It's 1. What about, we know I to the first should be 1. What's I squared going to be the same as? Now let's go in and let's do this. What about, what was your last one? Let's do this, kids. What about I to the 488th power? What's that going to be? Okay, what about type in that one that we had for 14. So 7, hang on, type in the one that we have for 14. So 7i to the 488 minus 3i to the 113 plus 5i to the 227 minus 6i to the 18. Type that whole thing in all at once, and type that in. What are you going to get? Oh, something's incorrect in there. Is that right? Hang on. Go over, what was typed incorrect here? Oh, because it has 6 over here. 6i to the 18. Press enter on that and change it to 6i to the 18. See, and that's part of the problem. You got to know. Now, does that match what we had? What's right here should be plus. All right, go hit that. Go change it again. That's why, loves, we got to make sure that we know the calc. Go back and change that to a plus. That's going to alter our answer slightly. But when we do this, could we go through and, I could train my little Raquito to go through and change. No? Okay. Now, for those of you, you got to know to type. Now, for those of you that want them, here's the answers for your homework. This is all, yeah. Here's the answers to your homework if you want them. Here's the answers to your homework if you want them. Make sure your calculators get put back in the right spot. Have a great rest of your day.
Or is it finished? Did you want me to turn it or dry erase?
Yes.
I didn't do that.
Check your mode. Let's go to menu. Go to your 5 for, let's see, document settings. Yeah, see how your answers in polar? We need it in real numbers.
I wasn't getting any of the right answers on my calculator.
That's probably why.
I was like, why?
Cancel. My documents. Save. Okay?
Yeah.
That's the ones that you have?
So,
That you missed? Okay, thank you very much. Use, always use Visibiz markers on it.
Okay. That's what I wasn't sure. I didn't know right on.
Yeah.
I wasn't sure if you reuse them every year.
Yes. They clean them off with rubbing alcohol at the end. Yeah, do me a favor. Put your name on here and put down what assessment number you think it was, and we'll just put it in as an excuse, all right?
I have these. They're
Okay.
from one day that I was absent.
Okay, thank you very much.
Do you stay after school?
Yes.
Sometimes? Okay.
Yep, until 3.
Okay. Today, could I come in and just like go over things?
I'll be after until 3 today.
Okay, thank you.
Okay?
What are you gonna do?
We'll just put it in as excuse. All right. That's good. Just leave that. That's enough. Okay? Thank you very much. So this was hers for something. Hang on 1 second.